what we were talking about last time. We're talking about Cartesian product and we're talking about Cartesian product of sets, right? And relation. What we discussed last time, relation is just any subset of A cross B. So now we'll try to understand why relation is a subset of A cross B or how subset of A cross B is a relation. Generalize this concept. Fine. Now can you see my screen?
Yes, sir.
Yes, sir.
Yes, sir.
Right. So let A and B non-empty sets. A and B are non-empty sets. So, the definition which we stated last time. So, a relation from set A to set B is a subset of A cross B. Right. So all of you know what is A cross B. It is a set of pairs. So that is what the definition I made last time. So if you want, I will note it again. So what is A cross B? It is a collection of pairs A comma B, where first component is from A and second component is from B. Right. So now, for example, so if I take, please keep your mic off. Do not keep mic on, otherwise it creates disturbance. Somebody has
So,
kept mic on. So suppose A is equal to A, B, C, and B is equal to two element set 1, 2. For example, for simplicity, just consider this. Now you know what is A cross B for these two sets. So A comma 1, A comma 2, B comma 1, B comma 2, B comma C comma 1, C comma 2. So these are the elements. And last time we also saw that how many elements are in A cross B. So the product of number of elements in this. So that we already learned that cardinality of A cross B is cardinality of A into cardinality of B. So cardinality means number of elements. So that we learned last time. Fine. So I will take R1. I will just take any subset of this. So I can take empty set. Right. So empty set. So empty set is a subset of every set. Is empty set a relation? Right. So empty set is a relation. Of course it is a relation. I will explain this later on, but why? That we'll discuss. I will take A comma 1, B comma 1. I will take only two elements from A cross B. So this is a relation. This is a relation means what? Ki A is related to 1. A is related to 1 and B is related to 1. What is the meaning of this? So with respect to relation R2. So this is my relation. I am defining relation between A and 1 and relation between B and 1. See, I can take another subset R3, A comma 1, B comma 2, C comma 1. So what this says, with respect to this new relation R3, A is related to 1, B is related to 2, C is related to 1. Right. So that is the meaning of this. So in real life, we have many such type of relations. So for example, let us see some real life example. So suppose my set X is set of all the students from A division. Right, suppose this is a set of all students from FY A division. FY A division. Fine. So I will define relation. So okay, first of all, what is my set A? The students. So S1, S2, all these are students. Suppose we have 120 students. So what is my last student? S120. Right. So I have 120 students in the class. Suppose, and so first student has roll number 1, second student has roll number 2, and last student has roll number 120. Suppose these are my students, right, in the A division. So so define relation. Define relation uh, R1 on X. Now my second set is also X. Not necessary ki second set is Y. First of all, suppose my second set is also X on X. That means from X to X. Suppose I define a relation from X to X. P as uh, for if you choose any two students from this division A, that means I am selecting X and Y from set X. That means I am selecting two students from X is related with this respect to this relation Y if X is friend of Y. X is friend of Y. So now you can understand how I am defining relation. Two students are related if they are friends of each other. That is my relation. That is I am defining, right? You can define some other relation that we'll see later on. But what I am defining is the student S1 is related to S2, right? If they are friends of each other. If not friends, then they are not related, right? Okay, let me make this notation. I will not make this notation right now. So X is related to Y with respect to relation R1 if. So what is my relation R1? When these two students are related, if X is friend of Y. If X is friend of Y, then only I am going to relate this. Therefore, if X is friend of Y, then what I can say ki XY is the pair is in R1, right? So pair is in R1. If X is not friend of Y, then this pair is not in R1. Right, so if when pair is in R1, if X is related with Y with respect to relation R1. When pair is not in R1, if X is not related to Y with respect to R1. So that is what the meaning of pair is in R1 or pair is not in R. So see, for the example, in case of previous example, A comma 1 is the pair is in relation R2. That means with respect to this relation, A is related to 1. Right. B is related to 1 with respect to this relation. Now, for example, B comma 2, this pair is not in R2. That means B is not related to 2 with respect to relation R2. Right. Or pair C comma 2 is not in this relation R2 because the C is not related to 2 with respect to this relation R2. Similarly, if you look at R3, so pair B comma 1 is not here because with respect to this relation B comma 2 pair, the B is not related to 2, or C comma 2 is not here because with respect to relation R3 C is not related to. So it may happen that some elements are related, some elements are not related, right? Or if you are looking at the students in the A division, it is not true that all students are friends of each other, right? Some students may not, so S1 is may not be friend of S10, or S3 may not be friend of S100, right? So that may happen. Therefore, the S1 comma S100 is not in this relation. So I will define another relation R2 on X, right? That means it is a subset of X cross X, right? I am defining another relation on same set. What relation I am going to define? So for xy belongs to the A division, x is related to y if, when they are related, if x and y are from same city, right? So x and y are from same city, then they are related. So for example, in the A division, some students are from Pune, some students are from Mumbai, some students are from Nasik, whatever. Some students are maybe from Delhi, whatever, right? So if two students are related, if they belongs to same city, right? So for example, if S1 and S10 are from Mumbai, right? So if S1 and S10 are from Mumbai, then what I can say, ki S1 is related to
S10.
S10, is it right? And so that I can say that ki pair S1 and S10 is in relation R2,
R.
right? Because what is my relation R2 in this case? Ki if two students are from same city, then only they are related. Therefore, S1 and S10 pair is in R2 because S1 is related to S10 with respect to this relation. Fine. Do you understand what I am saying?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
Very good. Suppose if S5 is from Pune. Suppose student S5, the student whose roll number is 5 is not from Mumbai, is from Pune. Then can you say that key there, and where is S1? S1 is from Mumbai and S5 is from Pune. Therefore, they do not belong to same city. They are not from same city. Therefore, S1 is not related to S1 is not related to S5, right? Why? S1 is not related to S5 because they do not belong to same city, right? S1 is from Mumbai and S5 is from Pune, right? And therefore, what we can say, the pair S1 S5 is not in R2 because S1 is not related to S5 because they are not from same city. Am I right?
Yes. Yes, sir.
Yes.
So that is what the meaning of relation, right? So suppose S9 is from Nasik, right? So but where is, and now the question is S1 S9 belongs to R2, right? Is
No.
no,
No.
right? Because S1 comma S9 is in R2 only if S1 and S9 are related. But what is my relation? The same city is my relation, but S1 and S9 are not from same city, so this pair cannot be in R2, right? So that is the meaning of relation. Now you understand what is the meaning of relation. So from same set I can have different relations, right? On same set I can have different kind of relations,
Sir,
right? So yes, somebody want to ask any doubt?
so in the bracket you have written x to x. So what does that mean? Can you explain?
Which bracket? This. Which
Above.
bracket?
Yes, sir.
Here. This. Because what is my definition? Relation from A to B. That means I am relating elements of A with elements in B. But my first set is X and second set is also X. So I am relating elements of X with X. So what is my set X? Students from A division. Students from A division. A student from A division is related to another student from A division if they are friends. That is my first relation. Or student from A division is related to another student from A division if they are from same city. That is my second relation, right?
Okay, sir.
Right. So my second set is I am assuming same set. Doesn't matter.
Excuse me, sir.
Yes.
Sir, is S1 related to itself? Can we say that?
It depends on your relation. In this case, no doubt, because S1 is a friend of everyone is a friend of himself.
Okay, sir.
That is assumption. If you are not assuming you yourself as a friend of yourself, you are not assuming you as a friend of yourself. That is a different story. But what is your usual perception? It depends on rules, right? If you are assuming that you are a friend of yourself, then this is every element is related to itself, right? Okay, let me give you one more example. Let X is equal to students from, okay, let me give the very precise notation. A, students from A division, right? What is B, students from B division, right? Now I will take different sets. If you have issue with same set, then I will consider different sets. Still I can have relation. So define relation. R1 from A to B as, so how I am going to define my relation from A to B. So the following is a relation for xy belongs to, for x belongs to A, y belongs to B, x is related to y if x is friend of y, right? So what is my relation? He I have students from A division A1, A2 and so on. I have students from B division B1, B2, B3 and so on. These are students. So this is the first student, roll number 1, roll number 2, roll number 3 and so on. Now how relation? So if A1 is a friend of B1, then certainly, so if A1 is friend of B1, then what I can say ki the pair A1 B1 is in R1, right? Pair is in relation. Pair is in relation. A1 is a friend of B1, then I can say that. And obviously B1 is also friend of A1. If A1, the friendship is not a one-way relation, right? Do you understand this? Right. So that is your perception. Whatever is your perception, that depends. But right now we are not interested in that. But the main thing is ki A1 is related to B1. That means the pair is in R1. If A1 is not friend of B1, then pair will not be in R1. That is a very straightforward. If A2 is a friend of A10, then this pair A2 comma A10 is in R1, otherwise not. Right. So it depends on what are the students, what is, are they friends or not? That depends, right? Fine. Okay, let me define relation R2 from A to B. Again, I am taking same sets as, but my relation is new, different relation. If for X belongs to A, you choose some student from A division, another student from B division, and X is related to Y with respect to relation R2 if X and Y have common subjects. So what are the common subjects? So have mathematics as a common subject. Okay, so both divisions have common subjects. So have common subjects. Both have. So what is not common subject? For example, uh, chemistry. as a common subject.
Genealogy.
So when I will relate two students, suppose I select one student from A division and another student, they are related if they have both have the chemistry as a common subject. If they do not have chemistry common subject, they are not related. Right. So now you can understand, and it may happen that some students are not related to some students here because they do not have common subject, or by relation R1 some student is not related to some student here because they are not friends of each other. So it depends on what is your relation, right? What is your relation? So now you can understand the relation clearly. Fine. So now let us come to our relation. So now, any doubt in the definition of relation? Any
No,
doubt?
sir.
Very good.
No, sir.
Suppose, suppose R is a relation from A to B, set A to B. Suppose R is a relation from set A to B. So if pair A comma B is in R, then we say that A is related to B with respect to relation R. Right. So if when pair AB is in R, that means a pair is in relation with respect to this relation. So A is related to B with respect to relation R. So we write it as is related to B. That means A and B are related with respect to relation A. Thus, AB is in R is equivalent to saying that A is related to B with respect to relation R. So that is a part of notation that you can understand. Right. So this is a clear now. The idea is clear. So let me tell you one more example. X is equal to the set of all family members. Right. So now you imagine your family and your family members. Right. And I will define relation to define X relation R on X. That means the relation from X to X. Right. So relation on X means X to X. As member M1, and so you take
So what's that defined relation?
define
What is that you have written? A defined relation R X. What is in middle?
so define relation R on set X.
Okay, sir.
Define relation R on set X. So what are the members of my set X? Family members, right? You can imagine your family. So now I am going to define the relation among family members. So for you take any two family members M and N in my family, uh, M is related to N with respect to this relation if M and N like same sweet. Right. So it may happen that different family members like different kind of sweet. Suppose two members like same sweet, then they are related. Right. So if two members like basundi, then they are related. Right. So suppose you in your family, suppose in your family there are M1, M2, M3, M4 and M5, 5 members, whatever. Suppose these two members like Basundi, right? So these two members like Gulab Jamun, and suppose these three members like Gulab Jamun, right? Which remaining, so all members are, but M2 like Gulab Jamun and M1 like Basundi, but M1 and M2 do not like Basundi, right? It may happen that ki M4 also like Basundi. It may happen actually because some members may like both of the sweets, right? That may happen. Now, can you write down this set R? Because the relation is a set now. The relation itself is a set, and it is a set of pairs. So, do M1 and M2 like same sweet? Do M1 and M2 like same sweet?
No, sir.
No.
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 No, sir.
But M1 and M3 like same sweet,
Yes, sir.
right? So
Yeah.
M1
Yes.
M3 pair is there. M1 and M4 like same sweet.
Yes.
So this pair is there.
Yes.
Very good. But so M1 and M2 is not there because M1 and M2 do not like same sweet. So M1 and M3 is there because M1 and M3 like same sweet. M1 and M4 is there because M1 and M4 like same sweet. Now I can have M1 and M1 also because M1 and M1 same member like same, and same member with same member is related with respect to this relation, right? Certainly this pair will be there because member is same.
So we can write the M3 and M4.
M3 and M4, very good.
And M3 and M3.
Very good. M3 and M4.
M4 and M4.
M4 and M3. M3 and M1. Because M3 and M1 like same suit, M1, M3 like same suit, so this pair must be there. Because these two, and I as
M4, M5.
that we'll write down later on, right? One more thing is which I missed out, M1, M3, M3, M1, M1, M4, M4, M1, because M4 and M1 like same suit and M1 and M4 also like same suit. So in that case, order doesn't matter. But these two pairs, M1, M3 and M3, M1 are clearly different pairs, as you recall the definition of order pair. Fine. Now, M2. M2, M1 is not here in the R relation because M2 and M1 do not like same suite, right? But M2 and M4, M2 and M4, and M4, M2 ultimately there because M2 and M4 like same suite, therefore M2, M4 and M2 also like same suite. Okay. Now M2, M5, they also like same suite and therefore ultimately M5, M2 like same suite. Okay, so M
M4 and M5.
M4, M5 and M5, M4.
M5 and M4.
Right. So anything missed out? Is there anything missed out? Right. So we have considered all the pairs and this is a relation. And once we understand what is the meaning of relation, what does it mean? With respect to this relation, M1 is related to M3, M3 is related to M1 and so on. And so this set gives a clear information about what is our physically, what is the relation among the family members. Right. So can you define one more relation among family members? Can you tell me one more relation?
Sir?
M5,
Yes.
M5.
Yes.
Sir,
Very good.
sir, in above you take M1 and M1, then M3 and M3 also take.
Yes. M3 is there. M5 is there because everyone like M5, M2 means M3 means same member and same member. They must like same suite because not different members. Right. So very good. So you should include these pairs also. is as far as this relation is concerned. Right. So suppose you can you define one more relation among family members?
M2 M2 Naila.
Yes, you can include M2 M2 because they M2 and M2 like same sweet, so that is there. Can you define one more relation among family members? X is related to Y. Now I am defining new relation, so I am calling it as R1, new relation, not like previous relation. If when X is related to Y with respect to new relation, if X and Y like same movie. Right, so this is a relation you can understand. Can you define one more relation? X is related to Y if X is brother of Y. Right, so in family member there are brothers and sisters, all members are there, but in that case it may happen that suppose mother and father or mother and daughter, they are not they are not related with respect to the R2. Right, or father and daughter or son and father are not related because they do not satisfy this relation. So if X is brother of Y, then the relation is there, right? So you can understand this. And what are the pairs? Okay, so this idea is clear now. Idea is clear.
Yes, sir.
Very good. So let A is equal to A, B, C, and B is equal to 1, 2, right? And you know what is A cross B, as we discussed earlier. A1, A2, B1, B2, C1, C2. So this is my A cross B. Now I will take relation R1 as empty set. What is the mean of empty set? Right. Okay. Let me give one more relation on family members. R3. X is related to Y if X and Y are from different cities. What is my set at X in my previous example? Family members. Is it clear? My set is set of family members. And now I am relating two family members if they are from different cities. Okay. Now what is the set in this case? R3. What is my set R3 in this case? If they like same sweet, then this is my set according to this assumption. Anyway, but if you are considering all the family members, right, and my relation is X is related to Y if they are not from same city. That means they are from different cities. So is it possible that the same family and two members are from different cities? Is it possible? Does
No.
no, there is no pair. There are no members which are from different cities. In fact, every member and so can we say that the member M1 and member M1, right? With respect to R3, can you say that member M1 and member M1 is related? M1 is related. So member M1 and this member M1, same member, can they from different cities?
No, sir.
No.
No. Very good.
No,
And
sir.
therefore, what is my set in this case? What is my set in this case? Empty set. And therefore, now when I say the empty set, because every subset of A cross B is a relation, so empty set means what? No member is related to any other member. Right? Is it clear now? What is the meaning of empty set or empty relation? Is it clear now?
Yes. Yes, sir.
Very. So therefore,
Yes, sir.
relation can be an empty set. And here is we have example X and Y are from different cities, then that is not possible for family members. Fine. So if I take R2 as A comma 1, B comma 2, right? So this is my R2. That means A is related to 1 with respect to R2, B is related to 2 with respect to R2. But A is not related to 2 with respect to R2. Is it clear? Because pair A comma 2 is not here, that means A is not related to 2 with respect to R2, or C is not related to 1 with respect to relation R2. That is the meaning. Because why? Why this?
Pair
Why?
is the
A
pair
comma
is not available in R2.
that means with respect to this particular relation, A and 2 are not related, right? But if I take another relation, A comma 2, B comma 1, then with respect to this new relation, because relation can be new relation, like the same sweet, same movie, whatever, you can have the different relations. So, but A is related to 2 with respect to new relation. Right, so some pair is not in one relation, that means it may appear in another relation. Fine. Now, how many relations you can have on from A to B? Right? How many relations? So the natural question is, how many relations? Are relations can be there from A to B? How many relations? Because what is a relation is a subset of A cross B, but how many subsets we can produce? Right, the answer is very simple now. How many subsets we can produce?
6.
How many subsets?
6.
How many subsets?
2 raised to n.
2
Right.
raised to n.
If cardinality of A cross B in this case is 3 into 2 is 6, and how many subsets? Subsets, set of
Raised to 6.
so set of subsets of A is power set of A cross B. And how many elements in power set of A cross B is the cardinality of it is 2 raised to cardinality of A cross B. It is 2 raised to 6. So therefore, if cardinality of A is 3 and cardinality of B is 2, then how many relations we can define from A to B? The 2 cardinality of A cross B, because a relation is a subset, and how many subsets you can produce, right? So how many relations you can produce? As many subsets of A cross B you can produce, right? And so how many subsets? So that you can understand. This is the one thing you can realize. Fine. Now we'll see more examples, but before that we'll need some definitions so that we can understand. Now the idea is clear. What is the meaning of relation, and how on same set you can have many different relations, right? If you have any confusion, you can ask, but I think idea is clear because these examples are sufficient to understand this idea. Fine. So let A be a set right? A be a non-empty set. Suppose R is a relation on set A. Now these two sentences clear? Any doubt in these two sentences? A is a non-empty set and R is a relation on A. I think there is no doubt because it is clear. So what I mean to say that R is a relation on set A. That means the relation defined among elements of set A. It can be any. There are many relations, right? There are many relations, like on family members, set of family members, you can define many relations, right? Depends on your cardinality of set. There are many relations. So you just pick up one relation from that, one relation among the relations on set A. Right, so try to understand each and every sentence clearly. Picture should be clear in your mind, then you can understand further part. So A is a non-empty set and R is some relation, right? R is some relation on set A. Then I want to classify the relations, right? There are different type of relations, so I want to classify. Then a relation R is said to be reflexive. Reflexive if every member of A is related to itself. Every member of set A is related to itself with respect to relation R. Right. So this is a definition of reflexive relation. So when relation is said to be reflexive if every member of set A is related to itself with respect to the relation R. So let me give you example. So that suppose my set is A, B, C. Now I am talking about the relation on set A. That means A to A. I am not considering another set B. And you can understand the relation from A to A. If I take relation R1 as AB, BA, AC. Right. So is it a reflexive relation?
No. No, sir.
Because question I can ask is A related to A, right? Is B related to B? Is C related to C? Because all members, there are only three members. So is A related to A? Is B related to B? Is. So this question is similar to is A comma A is in the relation. This is equivalent to saying that is B comma B is in relation R. This is equivalent to saying that is C comma C is in R, right? So this question, when this relation is reflexive, if A comma A pair is, unless A comma A pair is there, we cannot say that A is related to, right? Unless pair B comma B is there, we cannot say that B is related to B, and therefore this is not reflexive, right? So this is not reflexive because, so you write down the reason why it is not reflexive, because A is not related to A with respect to this relation, B is not related to B with respect to this relation, and C is not related to C. Fine, on same set I will define another relation. A comma A, B comma C, A comma C. So is reflexive?
No, sir.
Is it reflexive? Not reflexive, right? And what is the reason? Because B is not related to B. A is related to A, fine. But C is not related to, we are not in, when as far as we are talking about reflexive relation, such pairs are not important for us. What pairs are important? A comma A, B comma B, C comma C, right? So R3, A comma A, B comma B, is it reflexive?
No, sir.
Again it is
No,
not
sir.
related. No, right? So what is the reason? Because C is not related to C, because each and every member of A must be related to itself, that then only. Right, so A comma A, B comma B, C comma C. Is it reflexive?
Yes.
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 Right.
Yes.
So we are not worried about other, right? So for reflexive, we are only worried about whether pair A comma is there, B comma B is there, C comma C is there. That is important for as far as reflexive is concerned. but still this is a relation because it is a subset of A cross A. Moreover, every element is related to itself, so this is a reflexive relation. Fine. So now idea of reflexive relation is clear. Let me make one more example. So what example I can tell you is okay, so let x is equal to set of all lines in the plane, all lines in the plane, right? So what is my set now? All lines. So this is my object, this is one line, this is another line, this is line. Whatever possible lines you have in the plane, all lines are my objects, right? So define relation R1 on X as, now what are the objects? I want to choose one object from this set, right? Suppose I have a set of all students, and right, if my set is set of all students from A division, then what are the objects? Every student is object. So when I choose objects, then I should choose one student from that division. Similarly, my set is a set of all lines and I want to choose some objects. So what objects I should choose?
Lines.
Lines.
Line.
So I will select two lines, L1 and L2 from this set. Then L1 is related with respect to this relation to L2 if L1 is perpendicular to L2. Right, so two lines are related only if they are perpendicular to each other, right? So for example, this is my plane and I will select this line parallel to y-axis, and I will select another line. This is my L1 line and this is L2 line. Another line is parallel to x-axis. Are these two lines related? Are these two lines related?
Yes.
Yes, because they are
Yes.
perpendicular. If I take L1, if I select line y is equal to 1 and another line x is equal to 3, so this line is parallel to x-axis, this line is parallel to y-axis, and certainly these two lines are parallel, and therefore these two lines are related. But if I take a line x plus y is equal to 1 and x is equal to 2, are these two lines related? This is my L3 and this is my, so x plus y is equal to 1 is this line and x is equal to 2 is this line. Are these two lines related? You can imagine the x plus y is equal to
No,
1
sir.
is this line, and x is equal to the vertical line. So they are not perpendicular, certainly, therefore they are not related. So these two lines are not related, right? But these two lines are related. Now you can understand. Now, is this relation reflexive?
No, sir.
No, sir.
Right? So this relation is not
No, sir.
reflexive. Why? Why it is not related? Because you choose any line,
L1
you
is not
cannot
related
say
to
that
L1.
the line you cannot say that the line is perpendicular to itself, right? Why this is not reflexive? For any line in this collection of lines, L1 is not perpendicular to itself, because line cannot be perpendicular to itself. So therefore, the pair L comma L is not in the relation. So this is not reflect. Fine. Now I will define another relation. Define another relation R2 on X as for L1, L2 belongs to my collection of lines. L1 is related to line L2 if L1 is
L1
parallel to line L2. Suppose lines are parallel, then they are related. Right. Right. Suppose lines are parallel, then they are related. So for example, if I take line x1 is equal to 1 and x is equal to 2, x is equal to 1 and x is equal to 2. So what are these lines? Parallel lines. So these two lines are related. But if I take line x is equal to 1 and y is equal to 3, and x is equal to 1. They are not parallel, so these two lines are not related, but these two lines are related, right? So is R2 reflexive?
Yes, sir.
Yes, sir.
So,
Yes, sir.
yes, because every line is parallel to itself, that is clear, and therefore you choose any member of this. So why? You should write down the reason. If for every L in X, L is parallel to L, right? So every line is parallel to itself, and therefore L comma L is member of R2 for every line in X. For every, no line is missed out now. You choose any member of the collection of lines and you find that the line is parallel to itself. That's it. Therefore, this is a reflexive relation. Right. So now the definition of reflexive relation is clear. So the question is define more relations on this same set of lines.
Sir,
And yes,
sir, but in perpendicular relation, we can't find reflexive, right?
we can't find.
Reflexive means this reflexive.
What you can't find? I have given a relation which is reflexive. What you cannot find?
No, in perpendicular, we can't say that lines are reflexive.
Lines are not reflexive. Relation is reflexive.
Oh, sorry, relation is not reflexive.
So this, see, first R1 is not reflexive. The relation R1 is
Yes.
not reflexive. Why? Because you choose any line, you just close your eyes and put your hand in the set X. Set X is a bag, suppose, containing all the lines, right? So set contains lines. So you have a box containing all the lines. Just close your eyes and choose any line. Can you say that that line is a perpendicular to itself?
No.
Right, and therefore you choose any line, that line is not perpendicular to itself, therefore line is not related to itself, and therefore that this particular relation is not reflexive, R1, but R2 is reflexive because the relation is different and therefore it is reflexive. All right.
Yes, sir.
You can define many relations on the same set, right? So you can define the relation among two lines. So two lines are related if their angle is 45 degree. That could be another relation, right? So that is a relation. So you can define in this way, but whether check whether it is
Excuse me,
reflexive.
sir.
Yes.
If we say that L1 is parallel to L1, right?
Yes, every line is parallel to itself, no doubt.
Yes, but it may be happen that L1 is parallel to L2 or L3. Then it's not.
That is true. That is true.
Then
Okay.
how we can say that म्हणजे L is parallel to L is reflexive relation.
See, what is our question at this point? Is every line parallel to itself? That is it. That's it. L is parallel to many other lines. That is not an issue. Okay. For example, L1 is a line, x is equal to 1. L2 is a line, x is equal to 3. L4, L3 is a line, x is equal to L3 is a line, x is equal to 100. Right. So L1 is related to L2, no doubt. L1 is related to L3, no doubt, because these two lines L1 and L3 are parallel. That is there, no problem. But we are interested right now to whether L1 is parallel to L1, right? Whether every line is parallel to itself. That is our point of discussion right now. That is true that L1 is parallel to L2, L1 is parallel to many other lines. There are infinitely many lines to which L1 is parallel. Correct? For example, if I take line L is equal to x plus y is equal to 1, and if I choose another line M is x plus y is equal to 100. Okay, are these two lines related? x plus y is equal to 1 and x plus y is equal to 100. Right? And x plus
Yes.
y is equal to 1. Why do these two lines are parallel? Because their slopes are equal. When two lines are parallel, if their slopes are equal, and these two lines have equal slopes, so
They are
L,
parallel.
right, so L is parallel to M. That means L is related to M with respect to this second relation R2, no doubt. But moreover, L is parallel to itself. That is also true because x plus y is equal to 1 is parallel to itself. X plus y is equal to 100. M is parallel to M. That is also clear. Therefore, no matter which line you select in this, there are infinitely, uncountably many lines. Whichever line you select, the every line is parallel to itself. But this line, you select some line, this line is parallel to many other lines. That is not an issue because this line is related to this line is related to this line is related because they are parallel. That's it. Is it clear?
Okay. Yes, sir.
Fine. So that is not an issue. The line is parallel to many other lines. We are not thinking about that. That is clear, and you can understand to which line L is parallel. But we are just thinking about reflexivity. Is every line parallel to itself? That is our point of discussion at this moment. Fine. Okay, well. Now, among if you recall our previous all the examples, if you define relation among students from A division and I defined relation ki x is related to y, right? So what is my set? A division. A is the set of students in A division and x is related to y if x is friend of y. Right. So where are x and y? X and y are from same set because I am defining relation on same A division. So two students from A division are related if they are friends of each other. So is x related to x for every x?
Yes.
Yes.
Right.
Yes, sir.
Because every student is a friend of himself, no doubt, and therefore certainly this relation is reflexive. But if I choose some student x and some another student y, if they are friends of each other, then they are related, otherwise not related. Or if some student A and another student B, they are not friends of each other, they do not know each other, then they are not related with this relation. Right? So we are not worried about A is related to A is a friend of how many students. That is not point of interest right now. Right now we are interested in whether every element is related to itself. That is a reflexivity. Right. So let me go to the next definition, next type of relation. So symmetric relation.
Sir, it's 2.
Yes. So
Excuse
this
me,
relation, yes,
sir, is it necessary for relation set must be non-empty?
yes, because to define relation there should be some objects,
Okay, sir. Thank you.
right? So basically you have a set and then your relation can be empty set, but set should not be empty, right?
Okay.
Because the relation is a empty set means there is no relation among the students. Suppose you join the college and first day nobody knows each other, then nobody is a friend of other, and only thing is ki everyone is a friend of himself. That is true, but you choose any student, he may not have any other friend on the first day of your college, right? Therefore x no element is related to any other, every element is related to itself. That is there anyway, that may happen, as like we saw the previous example ki all the family members and they do not belong to same city, then they are related, then that such set is empty set. So the relation can be empty set, but we need non-empty set on which we want to define the relation, right? So is it clear now?
Yes, sir.
Yes, sir.
Right. So let A be a non-empty set.
Sir, it's 2 o'clock.
Oh, okay. So we'll define
Thank
this
you. So
next
can we
time.
leave?
Yes, yes, sure. So
Okay, thank you.
Hello, sir.
yes.
Sir,